We start a study unit on vectors and vector operations. We already know that when a quantity only has magnitude, it's called a scalar. And if it's got both magnitude and direction, then we call it a vector. And we know that vectors must also obey vector addition. Now, note the notation for scalars and notation for vectors for this particular study unit. We start by representing our vectors graphically. Note that in order to represent a vector properly, it is just a line segment that has its initial point at the origin, that is at point 0, 0, and its terminal point at that specified x coordinate and y coordinate. Here we'll just call it x1, y1. And we note that x1 and y1 are called the components of that particular vector. So we've got the x component as well as the y component for that particular vector. So note, every time we draw a vector, draw it starting from the origin 0, 0 to the terminal point that has been given. So here we've given you two examples where the first vector is 2, 3. So that means the x component is 2 and the y component is 3. The second vector is negative 1, 2. So that means negative 1 is the x component and 2 is the y component. Straight to operations on vectors. We start with equivalence. Equivalence also means equality. Two vectors are said to be equal or equivalent if they have the same length and direction. They must have the same length and direction. And algebraically, we simply say the corresponding components between the two vectors must be equal. So if two vectors are equal, their corresponding components must be equal. But when you draw them, they must have the same length and direction. Now, if we want to add or subtract two vectors, we add the corresponding components or subtract the corresponding components. We move on to scalar multiplication. When we multiply a given vector by a scalar, in this case we say our scalar is k, then it means we multiply each component of that vector with that scalar. If the value for k is positive, then it means both vectors are moving in the same direction. That means v, the original vector, as well as its scalar multiple. But if the value for k is negative, then that means the original vector and its scalar multiple are moving in opposite directions. As illustrated, here is the original v. 2 times v, 2 is our scalar. So that means 2 times v, vector v, will be twice the original vector, but moving in the same direction as v. But once we multiply by negative 2, it means we change the direction of v and multiply it by 2. So v and negative 2v are moving in opposite directions. Yes, negative 2v is twice the size of v, but the direction is opposite because of the presence of that negative sign. Yes. Examples, we go to number 1. We've been given two vectors u and v in 3 dimensions. That means x component, y component, and z component. So u plus v, we had said that when we're adding two vectors, we add the corresponding components. So well, I'm expecting that you add 0 and 1 so that we get 1 as the first component of u plus v. And then minus 4 plus 3 giving us minus 1 as the second component. 3 plus negative 2 giving us 1 as the last component. So we've got 1, negative 1, and 1 as your components for u plus v. Now 2 times v means each component of v is multiplied by 2. So I'm expecting the first component to be 2, second component to be 6, third component to be negative 4. You'll excuse my mouse, it's jumping all over the place. So 2 times v is 2 times 1, which is 2, 2 times 3, which is 6, and 2 times negative 2, which is equal to negative 4. And then, in order for us to be able to do C, which is V minus 3 times U. So we start with 1 minus 3 times 0. So that means the first component is 1. 3 minus 3 times negative 4. So minus 3 and minus 4 gives us positive 12. So 3 plus 12 gives us 15. And then the last one is negative 2 minus 3 times 3. So negative 2 minus 9 is negative 11. Please check and also visit other books and get more exercises to practice on. Then we go to number 2. U, V, and W are in fourth dimensions, and we are supposed to get an expression for x, vector x. And A has given us the formula that we're supposed to use. So it's 2 times u. So u is multiplied by 2 minus, and then you have v plus 3 times w. So you are subtracting v plus 3w from 2 times u. Can you please attempt it and see what you are going to get? The one thing that I'm sure of, your answer should be in 4 dimensions. And then we come to B. B has got, now we need to use the other properties so that we can be able to realize that we can multiply 3 to x and also 3 to w. So we have 3x here, and you also have x on the other side. So you can just use straightforward algebra, make sure that vector x is on the left and all the other vectors are on the right. So that means you'll have 3x minus x on the left. On the right hand side, we'll have 2 times u minus v minus 3 times w. And you work it out and make sure that you give us an expression for x. Now we move on to vector addition as was introduced in physics in high school. We start with the triangle rule. The head to tail method is the one that is referred to as the triangle rule. Now, looking at the first triangle that we have here, triangle OBA, we need to figure out which one is the resultant. Note that we have BO because of the direction, and we have OA. The first vector is BO. Why am I saying so? Because the resultant will always have its initial point at the first vector and its terminal point at the head of the last vector. So we move from the tail of the first vector to the head of the last vector. That's how we know that BA is the resultant. Hence, we have that expression that BA is BO plus OA. The resultant is always the sum of the original vectors. Also, with the second triangle, which is right-angled triangle, same. We have R, the resultant, being U plus V, because the tail of the resultant corresponds to the tail of the first vector, and the head of the resultant corresponds to the head of the last vector. Same with the third triangle. OB is OA plus AB using the tail to head method. We come to exercises. The first one, you are given a force 800 newtons in the direction north 35 degrees west. So that means 35 degrees will be between north and the force itself. So between the north and the force, you will have the angle 35 degrees. So the angle we're talking about is there. So you start in north going west. And then you need to figure out the x components and the y components. You need to remember from trigonometry, sine theta is opposite over hypotenuse. Cos theta is adjacent over hypotenuse. So adjacent in this case will be the x component. So we'll have x equal to r cos theta, and y will be equal to r sine theta. Please work it out and figure out which triangle are going to use. Are you going to use the triangle that has got 35 degrees or another triangle? And then we go to number 2. A man pulls a rope attached to a building. Note that we've been given the force that is 300 newtons east, alpha degrees south. So that means it's in the fourth quadrant. So you start east and going south. Now you've been given 8 meters and 6 meters. So we need to get the resultant and then find that angle, which is alpha. And then answer the question, what are the components? So first things first, you need to get R of that triangle with 8 meters and 6 meters first. And then thereafter, get the angle. And then thereafter, remember, we use Pythagoras theorem. R squared is equal to x squared plus y squared. So R squared will be equal to 8 squared plus 6 squared. So you get R, and then you substitute, and then use sine theta, cos theta, or tan theta to be able to find angle alpha, and then answer the question, find the components of the force. That's when you will use 300 cos theta and 300 sine theta. Number 3, we've been given a stump that is being pulled with a force of 250 newtons. And again, we've been given 7 on the vertical side and 24 on the horizontal side. So you need to figure out R, the small r there, using Pythagoras theorem. R squared equal to 7 squared plus 24 squared, and find R so that you can be able to find theta. And then thereafter, once you've found theta, either using tan theta, cos theta, or sine theta, then you'll be able to get the answer, because the answer says determine its direction. So that means what you're figuring out here is theta, the directional angle of P. Then we go to the parallelogram rule, which we need to remember from lower grades. The properties of the parallelogram, it has got opposite sides, equal, and parallel. So if two vectors have got the same initial point, then you can be able to complete a parallelogram and be able to get the resultant, which starts from the initial point of both vectors going towards the opposite corner of the parallelogram. That is our resultant. So using that information, we can be able to do the exercises. Remember, we have to, once you've got parallelogram rule, sine rule and cosine rule become effective depending on what you have. Here we had F1 and F2. F1 12 kilonewtons, F2 is not given, and we've been given that they form angles 20 degrees with the vertical and 45 degrees with the vertical. And also we've been given that the other corner of the parallelogram is 115 degrees. So if you were asked to find R and F2, the formula that would be most suitable will be the sine rule. Please go and revise the sine rule and the cosine rule and the reasons why we use cosine rule on certain problems and not the cosine rule, as well as the sine rule on particular problems. Number 2, again, we've been given two forces, F1 and F2, with one initial point, and as you can see, we've been given that F is the resultant. So what you need to do is to complete the parallelogram, put the angles in place. Note that the angles 30 degrees and 40 degrees are angles formulated by F1 with the vertical. So now once you've completed the parallelogram, you need to remember opposite sides of a parallelogram are equal and parallel. So once you have parallel, then that means fun comes into play. corresponding angles, alternate angles, and co-interior angles. So that you can be able to place 30 degrees and 40 degrees inside the parallelogram and then be able to figure out what are we going to use. Are we going to use the cosine rule or the sine rule? More exercises. Here we've been given 200 newtons, east 60 degrees north. You need to figure out which quadrant is that. And the second force is 400 newtons, east 30 degrees south. And these two forces are being applied on a boat. We don't have a picture here, and it's stuck in a shallow stream, so you need to determine the magnitude and direction of the resultant force. And so here I believe that we're going to use the parallelogram rule. Again, number 2, a son and his dad have attached a rope to a car and they are pulling with a force F in the X direction. Note that the force F has been given direction here, but then the rope breaks at the tension. So you've been given the tension of 400 newtons of F. And then what happens is that the man decides to attach both pieces of the rope and they both pull. Now they are pulling with different forces, both of them, Q and P. We need now to find the directional angles alpha and beta for both P and Q. Please attempt and let's see. Quickly, we move to the analytical representation of a vector. A vector in R3, in the space R3, can be represented in terms of I, J, and K. And note that we've given you that I is 1, 0, 0, J is 0, 1, 0, and K is 0, 0, 1. And they are unit vectors in the directions X, Y, and Z axis. Note that if we just gave you x's with components x, y, and z, so it means it can be written as xi plus yj plus zk. Now we need to complete these exercises. 2, 3, 5 minus 4i plus 3j. I'm hoping you're noticing that 4i plus 3j and those two are not in brackets. So please figure out whether 2, 3, and 5 subtracts 4i plus 3j, or minus 4 is just the x component of the next vector. So please figure it out. The second vector has got 2 components, I and j, but the first vector has got 3 components, I, j, and k. Do that operation and give us an answer. And then number 2, you do the same as well as number 3. Please attempt these problems and let's see what you are going to get. Then we quickly move to forces, because we have to find a way to resolve forces into its components by representing the forces appropriately. So in 2 dimensions, a force is given by fx plus fy. Note that fx is also a vector, and fy, remember, f is the resultant, so a resultant is always the sum of the other 2 vectors. Also in 3 dimensions, we have the same. Now, note how we describe these components. The vector fx is the length fx multiplied by I. Remember, When we don't have that dash underneath, it means it's just a scalar. So fx times I, fy times j, and fz times k represent those three vectors, fx, fy, and fz. Note that we're just going to quickly work with 2 dimensions here so that we don't get confused. Fx, according to our knowledge, the x component is always given by r cos theta. The y component is always been given by r sine theta. Note that for these forces, r, the resultant is F. So the x component of F is F cos theta x. And we specifying theta x is not the general theta of F, but the x component could have its own angle and the y component can have its own angle. And then remember, using the distance formula or the Pythagoras theorem, we know that the magnitude of a force is given by the square root of the sum of its components squared. Quickly, we go to examples. We are asked to write these components in an analytic manner. Analytically, that means fxi, fyi, that means f cos theta x and f sine theta y. P, vector P is vector px plus vector py. So let's quickly go to the solution and see what we are supposed to do. Here is the solution. As I was saying, we had said vector P is vector Px plus vector Py, which means is Pxi plus Pxj. And then P has been given to be 200. The angle P makes has been given, which is 60 degrees. So we've got 200 cos 60 degrees I plus 200 sine 60 degrees J. Note that we are just writing P analytically as a vector, so you can't leave behind I and J. Same with Q, but now the angle of Q is negative 45 degrees. Why 45 degrees? Q is 45 degrees east, actually south of east. 45 degrees south of east, so that means it's in the 4th quadrant. So it cannot be 45 in the 4th quadrant. We can write it as 335 degrees or negative 45 degrees. So the x component will be 400 cos for negative 45 degrees, and the y component is 400 sine of negative 45 degrees. Please don't forget to write I and J, because all you did here was to write those vectors in an analytic manner. They are still vectors, so they have components. So Q has x components 282.8 and has got y component which is negative 282.8. So I and J must feature in the solutions. Go to the next example. Number 2. We've been given this diagram and G has been given to be 100 newtons and H to be 130 newtons. The first question, what is the magnitude of the x component vector, x component vector of H. And then we write analytically the representation of both vectors. Now, before we go to our solution, we need to figure out something. Note here, we've got 5 and 12, so that means R using the Pythagoras theorem will be 13. So if I want theta for H, and I use sine theta, I'll have sine theta equal to 5 over 13. And if I want the y component, it means the y component will be 5 over 13. That's sine theta. X component, 12 over 13. Note what I've done in the solution. Also, here, H is in the second quadrant. In the second quadrant, according to the cast rule, only sign is positive. So that means the y component is positive, but the x component is negative. Hence then, to look for the x component, because remember we'd been asked to find the magnitude of hx. So I wrote here negative 130 times 12 over 13i. 12 is the x component that has been given in that triangle, because I believe we're given something like this. We've got 12 here and we've got 5 there. So that means the hypotenuse will be 13 and our angle will be here. But then this force is in the second quadrant. The x component should be 12 over 13 equal to cos theta. And cos theta in the second quadrant is negative. Hence, I've got here negative. In place of cos theta, I wrote 12 over 13. What you can do is to find theta. Find the value theta and do the same. The x component will be equal to 130 cos theta I, depending on the value of your theta that you got there. And remember, cos theta is negative in the second quadrant. So our answer for the vector should be negative 120 I, but the magnitude of that vector is just 120. Remember, magnitude does not have direction. That negative sign is giving us direction. So the magnitude is just 120 newtons. So you can do it in this format, writing negative 12 over 13, or find the value for theta. You'll find the same answer. And then B, we're supposed to write both vectors analytically. G is in the first quadrant, so there is no problem there. Both the x component and the y component equal to 0. Please check whether my triangle, I did it properly and I found the correct value for R. And please check whether G should be in that format. You can do the same. Find this angle, which is theta, and then be able to find R and find the x component and find the y component. And you do the same for H. Remember, we had already found negative 120i, so all we needed to do was to find the y component. Analytically, we are able to add vectors. That is why we are able to find the resultant. So if we've been given G and H, as we did in the last example, then that means the resultant is the sum of those two. And remember what it said, when we're adding two vectors, we're adding the corresponding components. So these are the x components of both vectors and y components of both vectors. Remember, we are not leaving I and j behind. So that means in order for you to get the x component of your resultant, you just add the x components of those vectors. If you want the y component of your resultant, you just add the y component of those given vectors. Let's do some examples quickly. Here we've been given P in analytic form and Q in analytic form, and we've been asked to find the resultant of these two vectors. So we do exactly the same. R is equal to P plus Q, and we add the corresponding components. So I added the x components together, 100 and 282.8. Note that I've not left I because R is a vector. It must have I and j. Also, we added the y components, 173.2 and negative 282.8. Formula for R then becomes that. But now, because R is a vector, you need to also find its directional angle, which we will call here theta R. We have found also here its magnitude, and we've also found its direction. Please check whether I did the correct thing in terms of calculations. Mind you, here we're not using radians, we're still using degrees. Number 2, we've been given 1, 2, 3, 4, 5 forces, and we are asked to find the resultant force. So that means first things first, and it has been specified. It must be done analytically. So that means each force must be written analytically first, and then you do the vector addition. F is equal to F1 plus F2 plus F3 plus F4 plus F5, and then add the corresponding components together and find also the direction of the resultant. The angle for F1 is 0. The angle for F3 is 90 degrees. And let me add here, the angle for F2 is 30 degrees. I think I left it out by mistake. 30 degrees. That's our angle for F2, 30 degrees east, north of east actually. And then we need to figure out the angles for F5 and F4 from what has been given. And then you add x components and y components together to get the resultant vector, which will just have one x component and one y component, and then find the angle using arc10. Number 3 of exercises requires you to use equivalence of two vectors, that is equality between two vectors. So as you can see, left hand side is one vector with its x component and y component. On the right hand side you have another vector with has got both components. So you equate the equivalent components or the corresponding components. Also you do the same and then be able to solve for x and y. And then we go to number 4, we're supposed to find the magnitude of F3. Its direction has been given. The other vectors with their directions, magnitude and directions have been given. So the first thing you need to do here is to make sure that you write each vector analytically, and then remember that the resultant R is the sum of all these 4 forces, F1, F2, F3, and 4, and then you equate the x components to the x component of R and y components of these forces to the y component of R, and then be able to solve for F. The magnitude of F3, note that its direction has already been given. Number 5, you are asked to find the resultant of those forces. And number 6, you are asked to find the magnitudes of P and Q. Please remember to check the quadrant of each of those forces. Check their quadrant so that you give us the correct directional angles in number 6.